Hey guys, what's up? I got this question online from a JEE practice exam. The question is, consider the integer n equals 9 plus 99 plus 999 plus ... so on, and the last term has all nines and consists of 321 digits. We want to find the sum of the digits of n. Pause the video, give the question a try, and come back when you think you know the answer. Before I go into my own solution, I'm going to give a hint. The hint is, try to think of another way you can write each term in this sequence. So, what's another way you can write 9? What's another way you can write 99? And so on, such that it becomes easier to find the digits of n. Let's get started with solving this. The first step is to understand that the only way to find the sum of the digits of n is first find out the digits of n itself. And in order to do that, we have to figure out what this entire sum ends up being. Now, obviously, if we add 9 plus 99 plus 999 and so on, it's going to be really tedious, and that's not the point of this problem. We have to think of a smarter way we can rewrite each term here in this sum such that it becomes easier for us to add all the numbers. Now, one thing you may have realized is that each number is 1 less than a power of 10. For instance, 9 is exactly 1 less than 10 to the power of 1. 99 is exactly 1 less than 10 to the power of 2. And so on. This last term over here is 1 less than 10 to the power of 321. So essentially you have a pattern going on here where each term is exactly 1 less than 10 to the power of the number of digits the term has. So we can start rewriting n as follows. Instead of 9, I'm going to write 10 to the power of 1 minus 1. Instead of 99, I'm going to write 10 squared minus 1. Instead of 999, I'm going to write 10 cubed minus 1. So on, so forth, where the last term is 10 to the 321, since it has 321 digits, minus 1. Looking back at the original expression for n at the top, we can see that it had 321 terms. So this was the first, and this was the 321st. Similarly, when we rewrote n like this, it still has 321 terms. And each term consists of minus 1. There's a minus 1 here, minus 1 here, minus 1 here, so on till the last term. So if we take all the negative ones out, we can rewrite n as follows. I grouped the 321 negative ones we had over here all together into this term, and I grouped all the powers of 10. So we have 10 to the first, which came from here, plus 10 squared, which came from here, and so on till 10 to the power of 321, which was part of the last term. It seems pretty clear that it's much easier to add all these terms than it would have been to add all these terms. Now let's work on finding what n actually equals, and we'll do that in parts. The first part is to calculate what this term is, and then we're going to subtract the 321. Looking at the first term, which is 10 to the power of 1, we get 10. Looking at the second term, we get 100. Looking at the third term, we get 1,000. Fourth term, we get 10,000. I think it should be fairly obvious that there's a pattern. So the last digit, when adding all the terms, would be 0. The 10th digit would be 1, since there's a 0 all throughout the 10th digit except right here. Similarly, the 100th digit would be 1, since there's a 0 all throughout here except at the top, and so on. So we know how the number looks. It's just a bunch of ones followed by 1 0 at the end. Our job is to find out exactly how many ones there are. And we can figure that out by paying attention to patterns. So if we just go till 10 squared, so if we add 10 and 100, our answer is 110. So when we stopped at 10 squared, our answer consists of 2 ones and then a 0. Now, if we went till 10 cubed, our answer would be 10 plus 100 plus 1,000, which equals 1110. This is when we stop at 10 cubed. So our answer consists of 3 ones and then 1 0 at the end. Therefore, we can conclude that when we stop at 10 to the power of 321, our answer should consist of 321 ones and then 1 0 at the end. So the total number of digits should be 322 digits in all. N simply equals this number minus 321. Computing the final value of n now becomes pretty straightforward. We can rewrite this large number over here as this. So I just took out 1,110 away from this large number, and this left term is what's left. So the end 4 digits all became 0. And now we just have to subtract 321. So all we really have to compute is 1,110 minus 321. Also, I forgot to mention previously, but no calculators are allowed. Anyways, we end up with this difference being 789. And adding this with this large number simply means changing the last 3 digits, so the last 3 zeros, to being 789. So n ends up being 11111 ... constant row of ones. And then we have a 0, so this 0 right over here. And then the last 3 zeros became 789, as we had to add this difference. And the total number of digits in n equals 322. And the question asked us to find the sum of the digits of n. Since we know that n has a total of 322 digits, and the last 4 digits are the only digits that are not 1, we can conclude that 322 minus 4 digits are indeed 1. So the sum of these first 318 digits over here is simply equal to 318, since you're adding 1 318 times. So now the sum of the digits of n is 318, which you got from the first 318 digits, plus 0, which is still 318, plus 7, plus 8, plus 9. After solving for the sum, you get your answer, which equals 342. That's it for today. See you in my next video. Bye, guys!